Okay, students, I'm going to do a review of Lesson 29 before I go into Lesson 30 because they're very important. They're very tied into each other. So I'm going to start off with a little bit of what our notes looked like. Okay. Rational expressions. When we're simplifying rational expressions, that means we're simplifying fractions. This happens to be fractions with algebraic expressions that are sometimes polynomials on the top and the bottom. Okay? And if you're just wondering, what do I do? What do you do? Well, you simplify. How do I do that? You factor the top and the bottom, and then you cross out like factors on top and bottom. So anytime you have the same thing on the top and the bottom of a fraction, you're allowed to cross it out. So, for example, right, real easy example, 2x over 3x. Well, what do I have that's the same on the top and the bottom? I've got an x and an x. They cross each other out. My final answer is just 2/3. If I had to simplify something more complicated, right, like if I had x plus 1 times x plus 3 over 2x plus 3. You'd say, what's the same on the top and the bottom? Well, the x plus 3 is here, and the x plus 3 here. My final answer would just be x plus 1 over, not 3, 2. X plus 1 over 2. Okay? So it doesn't matter if it's a single term, or a number, or a letter, or even a bubble, a parentheses, multiple terms, a binomial. If they're the same on the top and the bottom, then you can cross them out. So let me go into an example from Lesson 29 that we didn't do. I don't want to take your review opportunities from you. And let's talk about question number 21. Question number 21 is already factored. So I'm just going to look at what's the same on the top and the bottom. Well, you might look at 21 and 14 and say, oh, those aren't the same. But I can factor them. They have a common factor. What are 21 and 14 both divisible by? 7. So 7 times 3 is 21, and 7 times 2 is 14. Now, if I'm looking at the x's, x cubed and x squared, I know that I'm going to be able to cross out two x's because the x squared on the bottom, right? So I'm going to leave this x squared alone. On the top, I'm going to break off an x so I can rewrite it like this. Now let's go to the y's. Y and y squared. I'll be able to cross out one y because that's all I have on top. On the bottom, I'm going to break up that y so that I have a y to cross it out with. Now let's look at what's the same. 7 and 7. X squared and x squared. Y and y. So when I look at what I have left, I just have 3x over 2y. And that would be the answer for question number 21. Let's do one that requires some factoring, and then we'll move into today's lesson, which is multiplication. I wanted to go over question number 34. Okay, so question number 34. These are polynomials. They clearly need to be factored. The first thing I notice is these all have x's in them, so I'm going to GCF. Greatest common factor is x squared, leaving me with, on the inside, x squared plus x minus 2. On the bottom, I see a GCF of x cubed. So if I pull out an x cubed, I'm going to be left with x minus 1. If you get really good at this, you can just see it like I do. X squared, x cubed. I can cross out two x's on top, and I can cross out two x's on bottom, which would leave me with 1x left over. If that doesn't work for you, you can choose to rewrite it like this, x squared times x. Now x squared and x squared cancel out, and I'm left with that. You might think that you're done, and I wish that you were, but you need to factor the top first two. Okay? Math is about being specific and getting our answers exact. So on the top, I want to factor that as well. This x in the middle has a 1 on it, so what are two numbers that add to 1 and multiply to -2? Let me take that to the sidebar. -2 would be either -2 times 1 or -1 times 2. If they have to add to a +1, it's going to have to be these guys. 2 plus -1 would be +1. So I can rewrite the top as x minus 1, x plus 2. Just bring the denominator over. X minus 1. And then what's the same on the top and the bottom? The x minus 1's. So my final answer would be x plus 2 over x. Okay. Now I hope that helped with the understanding of how factoring helps us to simplify these rational expressions. Once again, I'll be checking all of your homework when I get back, so just hold on to it for now. Okay? Make sure that you're doing it to keep up with the lessons, because a day after I return, after we can do a little review, I'm going to give you guys a quiz on everything that we've done while I was away. So let's talk about lesson 30. Take out some notes, some scrap paper if you haven't taken out any yet, because you'll be getting a little bit of new stuff for lesson number 30. Multiplying and dividing, as complicated as they may sound, are actually the simplest things to do with rational expressions. Hands down the simplest. Now, let's talk about multiplying first. What is the goal of multiplying rational expressions? Well, I'll tell you one thing. It's not actually multiplying at all. It doesn't look like multiplication. It doesn't feel like multiplication. The goal of multiplying rational expressions is to factor top and bottom independently, and cross out. You're crossing out like terms even if they're across the multiplication sign. So let me start you off with a really easy example that's not on your sheet. Now, if you read your notes, you'll see that I put down right here, and you should have written it as well, that the goal of multiplying rational expressions is to factor the top and the bottom independently and cross out like terms even if they're across the multiplication sign. So that means I can cross out the same thing top and bottom even if it's on an opposite side from the multiplication sign. So look, 2 on the bottom, 2 on the top. Cross them out. X on top, X on bottom. Cross those out too. A Y on bottom and a Y on top, and everything is crossed out except for the 4 over 3. You get it? So multiplication is almost like pretending that they're already one giant fraction instead of two separate ones. So you can pause here if you need to write down anything or if anybody's still writing notes, but I'm going to go on to example number 2. I'm just going to rewrite it and take it over to my loose leaf anyway. So rewrite, question number 2 is 1 over 3x times 3x plus 12 over x plus 4. Pull this over to my notes. Okay. Now, nothing looks the same to me right now. I would love to cross out this 3x here with this 3x here. But the problem is that these guys are attached with addition, right? And we're trying to undo it with division. That doesn't really work. It has to be factored already, right? So what can I factor? Can I factor this? No. What about this? Is that factorable? Can I break that up into anything? Can I break this up into anything? I can't do any of those. The only thing that can be factored is this, because this has a GCF. So let me rewrite this. I can factor out a 3 from this, right? Making it x plus 4. See if I distribute it back in, it'd be 3x plus 12. Yeah. Okay. So let me rewrite. 1 over 3x times 3x plus 4 over x plus 4. Well, now it looks like I have things to cross out, right? What's one thing I can cross out? I mean, you don't want to call out, but identify for yourself. What's one thing I can cross out? Hopefully you notice the x plus 4s can both be crossed out. And so can the 3s. Cross them out, top and bottom. So what am I left with? Nothing but 1 over x, which is so much simpler than this. So much simpler, way better. That's going to be your final answer. Okay, let's take a look back at the front of the page. Simple GCF factoring, dots factoring. None of these look above and beyond. I'll give you a hint that this right here needs to be factored by grouping. So I'll run you through example number 7, and then you'll be responsible for the rest of the front of the sheet. Okay? So question number 7, let me just rewrite it. I'll take it to my loose leaf, and then I will take a rest, and you can get some work done. So I've got 2p squared over 1 minus 2p times 6p squared minus p minus 1 all over 3p plus 1. Pulls to my loose leaf so I have some room to work. Let's identify a couple things right off the bat, because I like to work smarter, not harder. Which of these are factorable? Can I factor that? Can I factor that? Can I factor that? I absolutely cannot. There's nothing to factor out. There are no GCFs. There are not trinomials that need to be grouped or double bubble factor. There's nothing going on here. So the only thing that I can factor and that I have to factor is this guy up here. So let me change his color so that I can color code all this. I just want to change what that looks like, because I don't like that. I know that it can be broken up, I just don't know how yet. 6p squared minus p minus 1. This is a polynomial. That means 3 terms. And it has a number in front. Right? This guy, he's messing it all up. So what do I have to do? You might recall that the coefficients are a, b, and c. I have to do a times c, that's 6 times negative 1, and 6 times negative 1, which is going to be negative 6. And now I need factors of that will add to b, that guy. So what could get me negative 6? I'm thinking negative 3 times 2, or negative 2 times 3, negative 6 times 1, or negative 1 times 6. It might take a little guessing and checking to figure out which pair is going to add to b, to negative 1. After your guessing and checking, you realize it's negative 3 and positive 2. So what I'm going to do is I'm going to split the middle term into two terms. I'm going to get negative 3p plus 2p. If you check and combine those like terms back, you'll find it's exactly negative 1p. After I split the terms, I bring down the other terms, so 6p squared and the minus 1. And now that I have 4 terms, I can factor this by grouping. So I'm going to get a GCF here. Remember that you want a GCF from each of these brackets. I'm going to factor out a 3p, leaving me with 2p minus 1. And on the right hand side, there's nothing to factor out. There's no GCF, so all I can factor out is a plus 1, leaving me with 2p minus 1. Now, if you paid attention through grouping, you know that I take the outside stuff, the 3p and the plus 1, and I make them their own bubble, and then the identical inside stuff gets put in the second bubble, 2p minus 1. This is equal to that. All we did was factor it by grouping. I didn't teach you guys how to factor for you to go ahead and forget about it. It's because we keep using them. So when I rewrite, I'm going to take this and rewrite it in this spot. So let's do that. 2p squared over 1 minus 2p times, let's rewrite the top, 3p plus 1, 2p minus 1, all over 3p plus 1. Now this is the best part. This crosses out, and so does this. And it looks kind of like we're done, right? Except this is a two-trick question. Grouping is not really a trick, but I know you think it is anyway, so I might as well call it that. This is a one-trick question, plus the expectation of you using grouping, which we already know. So when I rewrite this, let's do it one more time. This is equal to 2p squared over 1 minus 2p times 2p minus 1 over, was nothing, right? We crossed this out, it's gone, so we just put a 1 there, stand in its place. And you may notice that these two guys, let me highlight them for you, this and this, look a lot alike. Well, except for this one is positive, and this one is negative. This 2p is positive, and this 2p is negative. They're opposites. You can totally cross these two out. The only thing is it drops a negative 1 in its place when you do. Okay, so rewrite that. Negative 2p squared. That's what this becomes, negative 2p squared. So if you would love to see it's color-coded, it's negative 2p squared. Let's make them green. And that's what this is equal to, negative 2p squared, all over 1. And usually when you write something over 1, it's optional, so you could write it like that too. It's up to you. Okay? Now that trick always works if you have something that is like a minus b and b minus a. So like x plus 2 and 2 minus x. x minus 2. Sorry, x minus 2, 2 minus x. Those things will always cross out and give you a negative 1 left behind. We'll cover those sort of special cases in more detail, but I wanted to make sure that you were aware of them in case they pop up in any of these examples. Okay? Feel free to rewatch that section of the video because I am done with the instructional portion of today's lesson. You have responsibilities today. Your responsibilities are to complete the front of the sheet, the entire multiplication section. So you can end off right here. Here. Okay. If you finish all of those, you can relax because I don't want to touch division with half of a lesson left. Okay? So complete those, and hopefully you'll have no homework tonight. Good luck.